All right, chapter 4 is on alkanes and cycloalkanes. Hey, raise your hand if you already got a model kit. All right. When we get into conformational analysis, if you have a model kit, I recommend bringing it with you to class. It'll make your life a lot easier. I have a big model kit that I'll use to show you guys a lot of this stuff, but try to get a model kit for yourself or within your study group so that you can see some of the conformational analysis. All right, first part of chapter 4 looks at alkane nomenclature. So nomenclature is a fancy word for naming, and we've already seen a handful of naming conventions, so let's go over our hydrocarbon nomenclature. And most of you guys did pretty well with your functional groups. We've got alkanes, which are C-C single bonds. We've got alkenes, which are C-C double bonds. We've got alkynes, which are C-C triple bonds. And then we've got arenes, or aromatic, which is usually alternating C-C double single bonds. And I'll even fill in these H's here. So the main difference between all of these has to do with their suffix. So with an alkane, we end all of our naming with an ane as our suffix. We don't ever want to end it with an ene unless we're specifically referring to a carbon-carbon double bond. So let's take a look at some simple alkane structures, and I'm going to use bond line formulas from here on out. So let's draw a simple alkane. All right, we've got a bunch of different carbons in here, and the book will refer to these differently. So, if we look at a carbon that's only attached to one other carbon, like this one dangling off the end, this is called a primary carbon. Oh. These tend to be fairly reactive. If we look at this carbon here, what do you think this carbon's going to be? Secondary. It's attached to two different other carbons. So this is our secondary. And then over here we've got our tertiary, right? Pretty simple. We'll kind of see some of the reactivities, but tertiary carbons have their own unique set of reactivities that are different than primary carbons. And then last but not least, we've got our quaternary carbons. And we don't ever go above a quaternary carbon. Why not? Yeah, it'd be a Texas carbon. So we'll see primary, secondary, tertiary, quaternary. And occasionally, too, you'll see people refer to a methyl group, or a methane carbon, which is just a CH4 carbon, meaning it's not bound to any other carbons. All right. And carbons have their own prefix depending on the chain length, too. So let's go over chain length. All right, so let's make a nice little table, and in one column we'll have number of carbons. And then in the other column we'll have our prefix. And let's fill this out. We've got 1, 2, 3, 4, 5, 6, 7, 8. We'll go to 10. You can actually go above 10, but nobody really uses those. All right, what's the prefix for one carbon? Meth. Not like the drug, but like the prefix, right? So methanol. is a 1-carbon alcohol, right? That's what we distilled in lab the other day. What's 2 carbons? F. So ethanol is the drinking alcohol, not to be confused with methanol that will make you go blind. 3 carbons. Does anybody know 3 carbons? Prop. So propane, if you're a fan of King of the Hill, that's the 3-carbon natural gas. What about the 4-carbon? Bute. What about 5? Pent. Once we get past bute, we're going to start using Latin prefixes, and it becomes a lot more rational. So what's 6? Hex. 7? Hept. 8? Oct. 9? Known. This one's a little bit weird. And then 10? Dec. Known. So for example, if we had a carbon that was, or a chain that was 9 carbons long, and it was all carbon-carbon single bonds, what would it be called? No name. If it was 8 carbons long, what would it be called? Octane. So you oftentimes see that on gas stations. When you go up, it has an octane reading that lets you know how much octane is in your gasoline. All right, now we got to get into the more complicated aspects of naming. So simple naming is really straightforward, but things in chemistry are never simple. I'm sure you guys are aware of that. So let's get into a system of rules for naming. All right, prior to, I think around the 1950s, if you went to Germany, they had a different naming system for molecules than we did in the US, and the Japanese had a different naming system than we did. It was just a hodgepodge of names, and it became very, very complicated until we got together as a community of chemists and we decided we need to sort this out and all have the same rules. So IUPAC stands for the International Union for Pure and Applied Chemistry, and it's actually a meeting that's held every few years where they come up with a list of rules for definitions and naming. So they're the ones in charge of the naming system. I won't lie, it's really dry, it's very tedious, but we have to learn it. My old advisor said the reason we name things is so that we don't point and grunt at them. So we don't want to go, we want to actually be able to call them something, right? It's not fun, it's not something I like to cover, but we got to get over it. All right, rule number 1 is identify your longest carbon chain. So your longest carbon chain gets the designation as hexane or octane, where we'll label the longest chain at the end. There is a slight offshoot of this. If it's a ring system, meaning if it's cyclic, you want to identify the longest ring.
What is cyclic?
Just a second. So let's say we've got that molecule right there. That's a... all right, I'll leave it. How many carbons are in there? 6. So what would it be called? Hexane. Hexane can't be confused with this molecule, which also has 6 carbons. This would be referred to as cyclohexane to refer to the fact that it's in a ring. So we still need to identify the longest ring system, but when you're dealing with rings, you always deal with the longest amount of carbons that are within a ring. So only focus on the carbons in the ring system. All right, so let's make rule number 2 is list the substituents coming off the longest chain. So for example, you want to identify your longest chain as the backbone, so to speak. And then anything coming off of it is referred to as a substituent. So you may have a methyl group coming off of your backbone. You need to keep track of all of those substituents. Number 3 is number your backbone so that numbering is minimized. All right, let's take an example of this. Let's take this molecule. What's the longest carbon chain in there? 6, right? So when we go through and we name this, do we number going 1, 2, 3, 4, 5, 6? Or do we number going 1, 2, 3, 4, 5, 6? The red one, right? So in this case, the red numbering system puts the methyl group at the 3 position. The blue numbering would put it at the 4 position. So the red one wins out. That means that the name of this molecule would be called 3-methyl hexane, because we've got this methyl group coming off of this 3 position. Always try to minimize your numbering. It avoids confusion. And sometimes you have to check both of them.
Can you explain again why we have to do the red one again?
So in this one, if we're numbering using the red system, so from left to right, the methyl group's coming off of carbon 3. If we do numbering from right to left, meaning the blue numbering, the methyl group would be off the 4 position. So we don't want 4-methyl hexane because the numbering system is higher.
Okay.
So let's even write it and then just cross it out. All right. Number 4. Is you want to assign di, tri, or tetra if a substituent occurs more than once. So let's try an example of this one. All right, looks kind of like an X. What's our longest carbon chain? 3, right? All right, so let's go through and number it. So I'll just arbitrarily say 1, 2, and 3. You could have numbered any one of those and it would have been the same. All right, so it looks like off of carbon 2, we've got 2 different methyl groups, right? We've got a methyl group here and here. So if we have 2 methyl groups coming off of our chain, we refer to this as a dimethyl. So what we would call this is 2, 2 dimethyl propane. The substituents, in this case the methyls, don't have to be coming off of the same carbon. They can come off of different points in the chain. But you need to include that in your naming system. So you might have a 2, something else, and then a dimethyl. We'll practice this a little bit too. Yep?
Why do we put 2 twos and then dimethyl? I feel like it's kind of redundant.
It is a little redundant, but with longer and longer chain systems, you want to have the numbers representing where are the methyls located along the chain. So for example, you may have a methyl off of carbon 2 and another methyl coming off of carbon 4. And if they're coming off of the same carbon, you just do 2, 2. Yeah. Yep.
So this is just showing that there's a methyl coming off 2 lines. And 2.
Exactly. So the 2, 2 is saying we've got one methyl coming off the 2 position and another methyl coming off the 2 position. Exactly.
Why we still use the di?
Because they won't necessarily come off the same carbon. We'll look at some examples later where it will make a little bit more sense.
Okay.
Yep.
So if there's 3 methyl groups, would you do trimethyl?
Yeah, exactly. So if you got more than 3 off of there, you would do something, comma, something, and then try. We'll look at some examples of that, though. Oftentimes when we see these simple ones, it's like, well, isn't that redundant? It is, but we're trying to be as systematic as possible.
What's the first two relating to?
So it's saying one methyl group is coming off the second carbon, and the other methyl group is coming off the second carbon. So it's saying each methyl is coming off the 2 position, so we list 2 twice.
Oh, so each one is for each carbon.
Exactly. Yep. That's a part of the backbone, and so we're labeling that as the propane backbone. Yep. All right, let's do our last rule really quick. The last rule is alphabetize your substituents. There is a handful of exceptions to this. You want to ignore di, tri, tetra, etc. So don't include those prefixes if a group occurs more than once. So for example, if we're looking at dimethyl, we're not looking at D when we're alphabetizing for di, we're actually looking at the M for methyl. And then you also want to ignore tert and sec as you're alphabetizing. So there are some other substituents, such as tert-butyl and sec-butyl, which we'll cover. You don't include the T and the S when you're alphabetizing. They're omitted. You, in that case, would look at the B in butyl instead of the T on tert. So ignore those prefixes.
Also, can you repeat what you said for the first one?
Yeah, so like in the last one, when we had dimethyl, we wouldn't alphabetize according to the D. We would ignore the di and instead look at the M on methyl. Yeah. So ignore prefixes when we're alphabetizing. Yep.
So like if it was dimethyl ethyl, it'd be diethyl methyl?
Exactly. Ethyl would come before methyl. All right, let's take a look at one example before we get started. And I want us to name it. So the first example is actually the one I gave us before, and we need to come up with a name for this. So what's the longest carbon chain? 6, right? All right, so now the question goes, do we number it 1, 2, 3, 4, 5, 6? So right to left, or can we number it using the blue system of 1, 2, 3, 4, 5, 6. So just for the sake of argument, let's write out both of them, right? All right, so we've numbered our backbone. We've got a substituent coming off of here. What's that called? Methyl. We've got substituents coming off of here. They're both methyls. And we've got a substituent coming off of there. All right, so if we're using our red nomenclature, this would be 3, 5, 5, indicating we've got methyls coming off the 3 position once and the 5 position twice. And then what would the rest be? Yeah, trimethylhexane. Or, if we go with the blue system, we would say, all right, this would be 2, 2, 4 trimethylhexane. Which one's preferred, the red or the blue? Blue. Blue, right? Why are we preferring the blue? Yeah, we're trying to minimize the numbering. So 224 beats 355. It's got a lower numbering system. We're going to practice this more tomorrow. On your problem of the day, one of the problems I think has an isobutyl and a sec-butyl. Try to look up those substituents in your textbook or just Google them and you'll be able to pull them up. That'll help you a lot when you're going through and drawing those, but we'll cover some of the weird substituents tomorrow in class a bit more.